If you struggle with LCP, then this video is just for you. Chatellier's principle, or LCP for short, states that if a closed system at equilibrium is disturbed, the system will adjust itself to minimize and counteract the disturbance. Consequently, a new equilibrium is established. Sounds like a crazy bunch of words, right? Don't worry. By the end, it will all make sense and LCP questions will be easy marks. But first, let's unpack a few concepts. Let's remind ourselves, what's a closed system? Well, a closed system is one that can exchange energy, but not matter, with its surroundings. It's kind of like having a cup of hot water with a lid on it. Nothing can evaporate out, but if you leave it out long enough, you'll lose heat energy to the surroundings. Cool. Now that we get that, what's a dynamic equilibrium? A dynamic equilibrium exists where a reversible reaction takes place in a closed system, and the concentrations of products and reactants are constant. Now that those two things are out of the way, let's get into what LCP is. LCP essentially says that if you have a system at equilibrium, and you do anything to disturb this equilibrium, then the system does everything it can to oppose it. Some of the disturbances you might have are changes to concentration, temperature, and pressure. Today, let's look at concentration. Now let's use this reaction as our example. To make this easier, let's think of LCP like a grumpy old grandpa who doesn't like change. Say you increase concentration of nitrogen dioxide, making the syringe a whole lot more brown, since NO2 is brown. But our closed system at equilibrium, aka grumpy old grandpa, doesn't like this. So what happens? He wants to get rid of this change. So grumpy old grandpa, or the system, will use up the extra NO2 to counteract the initial change in adding NO2. To do this, we favour the forward reaction. So effectively, NO2 is used up, and as a result, extra N2O4 is produced, since we favoured the forward reaction. And eventually, equilibrium is re-established. What's really interesting is that the syringe will now be less brown, as you've used up NO2, but still more brown than when you started. Why, you may ask? This is because equilibrium systems don't overcompensate. As you can see, the final amount of NO2 will always be a bit more than when it started. The best way to think about it is grumpy old grandpa gets his way, but not all the way. So there you have it. That's how a closed system at equilibrium reacts when the concentration of one of the reagents is changed, according to LCP. By the way, grumpy old grandpa is just here to make this concept a little bit easier, and is just an analogy. The real reason why LCP works the way it does can be explained by collision theory. But that's part of a different syllabus point and a topic for another day. So remember to subscribe so you don't miss our future videos where we will go through how equilibrium systems behave when other changes are made. See you in the next one.